Good afternoon all, and I am going to present regarding the Linux networking training, which is we are going to conduct with the MindMajix. MindMajix, your skill partner. This is the demo for the Linux networking training. Okay, I'll jump into the scope of the demo. We are covering the number of things in this course. Out of that, today we are going to be represent regarding TCP/IP basics and setting up the Linux networks. Okay, this is the course outline, which will covering number of topics, which are introduction of networking, TCP/IP basics, setting up Linux networks, standalone services, inetd and zinetd, remote access, secure shell, DHCP servers, bind DNS servers, remote procedure calls, the network file servers, which we can like abbreviation is like NFS, also NIS, like network information services, modem, ISDN, and PPP. And we are not going to cover all these points. Only if we feels like if we can add any more topics which are related to this course, those topics also we can add as per the requirement. For example, I have added some topics as per the network basis, like scanning of TCP and UDP ports, overview of network manager, configuring IP networking and NMTI, NMCLI. These are the some add-on topics are there, and we can add some more points also, like topics also, if requirement basis. Okay, additional course resources. Okay, MindMajix is providing the material also. Along with that one, I'm referring the standard Red Hat documentation only. Okay, going to the next size. After completing the projects like a course, we have to perform some project activities also, to verify the knowledge of the candidate, and if you want to explore his knowledge in more perspective. Then I have mentioned here some two projects, like creating pilot setup for the own DNS, DSCP, and environment. Like this project will include his own DNS server, DSCP server, and some clients also in that one. Like this setup will work. What are the FQDN means fully qualified DNS names are there. Okay, those will be hosted those will be resolved from the that setup DNS server itself, and whatever the IP address will get, that DSCP server also we are going to be host. Like this is a huge project, we can say. Like we need to configure the DHCP server itself, and that should be accessible throughout the LAN network. And in same LAN, we are going to be include the DNS server also, and host IP address means client, whatever the clients will be there. Whatever the clients will give the request on the basis of IP address or FQDN name. Okay, those both of the things I will verify. We will set up that kind of environment, like that should resolve to the DNS server and DHCP servers. DHCP server will give the IP address detail, and DNS server will resolve the DNS names against that IP address, whatever the IP address client IP address is getting. Okay, and the second projects I would like to explain, this is network monitoring. Like nowadays, this is the need of the monitoring. Okay, because what is happening inside our network. Okay, whatever LAN network we can say, or WAN also we can monitor, but WAN we are not considering most of the time. LAN network we can monitoring, like net stats commands are there. There are a number of commands in Linux itself. We can monitor on command line basis also, and I am going to include some of the monitoring tools also along with Linux OS. Then we can monitor all the LAN network, and we can include these two projects with each other, because whatever the happening in DNS, DSCP, and client, those things also we can monitor, and we can properly share with the like a, means students can understand what is exactly happening in their exact network. Okay, I'll go to the next slide. This lab setups is required, like a high speed internet is required. Desktop or laptop is fine. Anything out of this, if they are having desktop or laptop. And minimum requirements is Microsoft Windows 7 or above. Okay, means if it's 8 or 10, that will be very good. And the hard disk requirement is 500 GB SATA or SSD, whatever the type of hard disk they are having. Memory up to 16 GB, from 8 to 16 GB memory is required, and CPU 4 cores are enough to perform this kind of practicals also, and sessions whatever that we are taking, those also we can cover in this kind of the lab setup. Okay, and mock interview kind of things, like after completion of this course. Okay, we conduct the mock interview to the participants who wants to evaluate themselves before applying for the job. Okay, because some of the time students are getting the knowledge only like a lab kind of environment, then they will go for the actual interview. They are not aware about what is the actual things is going in industry. Okay, then to avoid that knowledge gap, we are conducting the mock interviews, and we are telling like what is exact requirement of that application. Suppose if we are telling teaching one of the topic, what is the actual use of that topic, those kind of things we can cover. Okay, and we can conduct the interview, and we can cover the topics. Those will help to candidates while going into the actual interview, like a scenario based question. This is like a good word for that one, because topic wise questions anyone can cover. Okay, but when they will get the scenario kind of question, then most of the student will get stuck. Okay, because they are not having awareness and idea about what exactly happening in network, what exactly happening with that exact OS. Okay, those kind of things are those that now knowledge gap we will try to cover up in this mock interview kind of thing. Okay, and certifications, like there are a lot of certification related to networking, but these are some basic. RSCSA is the first kind of basic kind of certification, and if a candidate is interested for the advanced certification, you can go with the RSC also. Okay, this is based on the interest of the candidate. We start with this TCP/IP reference guide. Okay, I would like to introduce what is the TCP/IP exactly. Okay, this is the reference guide where we will discuss about the TCP/IP networking. These are the basic protocols which are going to be used in the all over the networking world. Okay, and although we are going to be discuss about the Linux servers, Linux users, or whatever the students will be there, those are Linux administrators. But this concept are going to be applied all over the OS, whatever the OS we are using all over the globe, and whatever the networking device which are going to be used. Okay, TCP/IP primarily used for means whatever the explanation I am going to give here. Okay, though that is going to be only for the IPv4. TCP/IP networking, this is abbreviation is stand for the transmission control protocol and the internet protocol. Within the TCP/IP networking protocol, there are a lot of more protocols which are involved: TCP, SCP, SSH, FTP, FTP, and whatever the application layer protocol, like we can say SMTP also, SSH. It will cover all are the protocols which are worked day by day basis, like whatever the users will be there, whatever the host will be there, servers, client, whatever the communication will happen, that will based on the protocol basis only. Okay, related protocols I have mentioned here, TCP and UDP. Like okay, we'll explain these protocols in OSI model also. This is the OSI 7-layer model, and mostly networking protocols are described related to the OSI model. OSI stands for Open System Interface. Okay, and functionally we can start from the physical layer, like a physical layer. This will consist of the 7 OSI layer model. Okay, and if we start from the physical layer, data link layer, network, transport layer, session layer, presentation layer, and application. Whatever the communication is happening between server and client, or client to the server, that packets and that process has to go from the layer 1 to layer 7. This is 7-layer OSI model also. We are popularly telling this. I'll explain each layer briefly. This is the physical layer, which is the media, like whatever the physical things which are covering. Okay, whatever the physical things we can touch and we can feel, those kind of things are covered in the physical layer. Like describe media over the data travels for the instant. This describes the voltage of 0 1 signal, whatever the signals are there, like bits and bytes. Okay, these things are going to be covered in physical layer. Whatever the things, like what are the cables, connectors, these things included in physical layer. Now we'll check for the data link layer. Data link layer is the layer 2, second layer of the OSI model, and it consists of the MAC address mainly. Okay, whatever the layer 2 protocols, like commonly we are calling switches, are the layer 2 devices. Like switches will mostly work on the MAC address basis, like what are the destination and source MAC address will be there. Those things are added, and those protocols will like work in symbolic representation in data link layer. Describe the means by which the bits are carried across the physical layer. Okay, means whatever the things are carried out in physical layer, those are the things are included in the data link layer. For examples, like how to start and end of the data stream indicated, like whatever the data stream means mostly it will be included the MAC address only. Then in this representation, third layer is the network layer. Okay, this is the most important layer, like where source and the destination MAC address, the source and the destination IP address is the described. Okay, all the layer 3 routing devices, like routers and layer 3 switches are included in this network layer only. and network layer only will decide like on which network the traffic is routed. Okay, all traffic protocols, routing protocols will work on the network layer itself. And we'll come to the fourth layer, which is transport protocol. This is transport layer. Okay, here TCP and UDP stands here. TCP stands for the transmission control protocol, and UDP stands for the user datagram protocol. Okay, these are the two protocols are responsible for the transportation of the whatever the protocols and data is carried out from the layer 2 to layer 7. Then will come TCP stands for TCP. Like this is if we give the brief description of TCP and UDP. TCP is the connection oriented protocol, and UDP is the connection less protocol. Whatever the transmission like broadcasting or VoIP calling, those kind of things are covered in the UDP. And TCP consists of the downloading any one of the file. TCP can cross check and acknowledge the fields like if we are downloading 1 GB or 2 GB, whatever the data or ISO file. Okay, if you are going to miss any packets, then TCP protocol will check, and if any packets or if any data is missing, it will retransmit the those missing packets in later session. Okay, then we'll check for the session layer. Session layers is responsible for the establishing, managing, and termination of the session between two hosts, like we can say server and client also. Okay, and the next layer comes under this things, which one is the presentation layer. Okay, presentation layer mainly responsible for the formatting of the data. Okay, means whatever the data is coming from the host, one host and to the another host. Okay, it's going. Then there are number of schemes are there like ASCII, and some are using other than ASCII. Then that data will not be readable to the another host. Okay, then that kind of representation is happening in this layer only. Suppose sometimes if we are standing in front of laptop and we have opened the browser, whatever the data is coming, we don't know like which format that data is coming. Okay, then on that basis, suppose if we have opened Outlook, then it will convert those type of data in SMTP format. If we are using FTP protocols, okay, then it's a like a presentation layer work like how it will reformatted into as per our purpose. Okay, and last layer application layer, which is like whatever the applications we are using, which I have already explained, like email will use the SMTP protocol. Okay, browsing of the web, it will consist of HTTP and HTTPS, both of those things. Like we can say number of protocols are there which are included in application layer. Then will come, this is the OSI reference model which we have discussed now. Okay, this was considering 7 layers. Then what is exactly TCP? Then TCP was originally developed for the universities of the military to exchange the ideas and files. Okay, this is like a initially developed in between lab. That lab name is Internet Architecture Board Lab, like IAB lab, we can say that one. Development of standard is handled by the Internet Engineering Task Force, IETF, we can say that one. Initially, it is developed for the military purpose and file transmission between those only. Then it is compared with the OSI layer. Okay, I'll share you what are the RFC documents we are considering. Okay, those things are also like monitored by IAB. Okay, which is Internet Architecture of Board. I'll show you. This is the TCP/IP stack. Actually, if you compare with the OSI layer, okay, here all three upper layers are means combined in a single application layer, and they have removed some of the layers also to minimize this one. I'll show you in next presentation like how to compare with the OS. Here we can say if we go from like bottom, here physical and data link layer is there. Okay, now in case of TCP IP stack, what they did, like they have combined these two layers, and network access layer they have formatted here. Okay, and network layer become the internet layer here, and transport layer as it is like TCP IP is happening there. Means all communication is the in same way only, but the formation of this TCP IP stack is like somewhat different compared to the OSI model. Like we can say upper three layers are like combined to the application layer. Then I will go for the further topics in the TCP IP stack. Like IP addressing scheme is there, like IPv4s are also there, and IPv6 are also there. Before going into those topics, also I would like to explain this like what is the bit, byte, and how that we are considering. Like bits are the 0 and 1 representation. Like whatever the data is moving, this is moving in the format of the bits only. Either that will be 0 or 1. Then if that 8 bits means 1 byte we can consider. Okay, then if we go with these schemes to the towards the IP address, actually I would like to explain about the IP address first. Okay, IP address is the unique thing, okay, which we are going to be assigned to the whatever the host device or the client device. Then whenever they wants to communicate between two hosts, okay, then they will consider as a unique IP address. Like on the basis of IP address basis, only two hosts can communicate with each other. Okay, suppose if two hosts are there in network, then each should have unique IP address. And whatever the packets will IP packets will send, then IP packets will be considered as a source IP address and the destination IP address. In that IP address scheme, we are having 5 classes are there. Okay, but out of 5, class D and class E are not used for the commercial use. I will explain here these 3 classes first. Okay, which will be consist of the network bit and the 3 host bits. I'll explain like this all consist of the 32 bits only. Whatever the 4 chunks are divided, those are 8 bits of bytes of chunk, and if we consider like 8 bytes of network bytes, okay, and all remaining 24 bytes are the host bytes here. Okay, and if we consider for the class B, then 16 bytes are the network bytes and 16 bytes are the host bytes. If you go for the class C, then 24 bytes are the network bits and 8 bytes are the host bits. Okay, this binary representation I am having, that binary representation I have added in the upcoming slides. Okay, for now you can consider like how many classes are there, and on what basis that class representation is divided. Like this is decided on the basis of how many network bits are there and how many host bits are there. Okay, on that basis it is decided. Okay, I'll share this class starting points and the class range, and the whatever the private IP addresses and what is the public IP addresses, those information I would like to explain here. Actually class A starts from the 0.0.0.0. If I will say like whatever the IP address scheme is there, okay, this is starting from the 0.0.0.0 to 255.255.255.0. Like this is the last point of this IP address scheme is there. Means this is IPv4 only. IPv6 consists of the different ranges in that one. Class A starts from the 0.0.0.0. Class B starts from the 128.0.0.0. Class C starts from 192.0.0.0.0. Class D starts from 224.0.0.0. And Class C starts for the 240.0.0.0. I have already mentioned like class A, B, and C we are practically using. Class D is used for the multicasting and the broadcasting kind of things. For those reasons, it's going to be used. And class C is purely used for the research purpose only. Okay. Then in practical use, we are only using three classes like class A, class B, and class C. Okay. There, then I will mention this range here. Classes starting from 0.0.0.0 to 126.255.255.255.255. And class B starts from 128.0.0.0 up to 191.255.255.255. Class C starts from 192.0.0.0.0 to up to 223.255.255.255. Class D starts from 224.0.0.0 to 239, 255, 255.255. Class E starts from 240.0.0.0 and it ends with 255, 255, 255.255. Okay, these are the ranges, and it's not like a we can decide on the basis of these classes also, but it's not like every IP address anyone can use. There are like some of the IP address which are accessible throughout the internet. Those IP addresses are called the public IP address. Like whatever the host you are having, and if you are having internet connectivity, you can ping the IP addresses, and that IP addresses we can consider as a public IP addresses. Okay, those IP addresses are managed by the IANA, like Internet Authority is there, IP address authority. Those are only going to be provide the IP public IP addresses. Like those are IP addresses monitored by the. Suppose if we want public IP addresses, then we can contact to the nearest ISP, Internet Service Providers. They will give the public IP addresses to you, and those are the paid IP addresses only. Then how we can use the IP addresses to the our local host, means whatever. Suppose if I want to set up any LAN network inside my home or a small office or this kind of thing, right? Then for that reason, that organization has given the private IP address ranges per class. Okay, Then these are the private IP address ranges. Like class A private IP address range start from the 10.0.0.0 to 10.255.255.255. Okay. For class B, 172.16.0.0 to 172.31.255.255. For class C, this is 192.168.0.0 to 192.168.255.255. Then why we are using like why we have these two types of private IP address ranges and public IP address ranges. Suppose if we are having small office, okay, then we don't need to be purchased for the single PC IP addresses for the each and every PC. Okay, we can do the netting kind of things. Okay, if that points are included in this course, those things also we will explain. Like for the office and those kind of things, we don't need to purchase the IP addresses. Okay, then there we can assign this private IP address ranges. Suppose if I am going to use 192.168.0.0, 1 dot slash 24 network we can take. Okay, and those IP addresses we can assign to inside our LAN only. And whenever we want to communicate to the internet, okay, that time only we need the public IP addresses. Then those public IP addresses we can get from the internet service provider, like whatever the broadband connections we are taking, right? Then NAT is happening against these private IP addresses. Okay, this is some another topics. If it's covers, if it's includes in our this course topic, those things also we will include. Okay, I hope this will clear the like points between private IP addresses and what is public IP address. And public IP addresses are paid by, means we need to be pay the money to use the public IP addresses, and we don't need to pay for the using the private IP addresses. Okay, okay, then here I have like explained some binary representation. Okay, these are the reserve IP address. Okay, if you guys have observed here, like class A starts from the 0.0.0.0 to 126.255.255.255. Okay, here 127, that total range is missing. Okay, that IP address range is completely used for the loopback IP addresses, which is 127.0.0.0.0. These like whatever the host are there. Okay, if you ping from your command line, then you can ping to the 127.0 dot, like internal reachability between the network interfaces within same host only. Okay, this kind of things, for verification of this kind of thing, we are using this reserve addresses, like loopback also we can say for this one. And now we will come to the subnet mask. Okay, then how we will decide what is subnet mask, okay, against that IP addresses. This is a binary representation I have given, like a subnet mask. Okay, I will subnet mask tells us the which part of the IP address is the network part and which part is the host part. Initially I have mentioned, okay, whatever the classification is going on, like class A, B, C, and D. Okay, that is on what basis, like how many network parts you are having and how many host parts you are having. Okay, that will be going to be decided like what is the subnet mask you have to use. Here I have taken 192.168.1.0 IP address is there. Okay, and here it's a representation, like this is binary representation of the IP address. This is decimal IP address, whatever the we are considering 192.168.1.0, right? Then wherever it is one means it's a network part, and whatever the representation is zero, that is host part. Like one, two, and three, like three network parts and one host part. Like this will be coming into the class C only. If you want, I can go back. This is class C. Okay, three network parts and one host part. Okay, like that we can consider. And to decide the what is the network part, okay, to represent that figure, like whatever the number is there, for that representation we are using the subnet mask kind of thing. Okay, here 255.255.255.0, what is mean, like whatever the 255 I have mentioned, like all these bits are the masked. Like we are having slash 24, 8 bits here, 8 bits here, and 8 bits here. Okay, means all 24 bits are the, yes, 24 bits are the subnet marks only. Then okay, on that basis we can decide. Wherever zero it's mentioning, this means this is the host part of that 32-bit IP addresses. Okay, means 24 bits are the network bits, and whatever the 8 bits are remaining, those are the host bits are there. Like those we can host range will be from 0 to 255. Okay, how we can decide like 0 to 255 host range, like 2 raised to 7, 2 raised to 8 we need to give, like 8 bytes are there, that's what we can use 2 raised to 8, and then it will become the 255. Inside that one also we can't use all 255, means actually number those are 256 because it's starting from 0 to 255. Okay, but first IP address is the network IP addresses, and last IP address is the broadcast IP addresses in that one also. Okay. Anyway, we are covering in next slides. Okay. There I am going to be explain about what is IP address also, and gateway IP address and subnet mask, which I have explained here only. Like where we are getting the network bytes, those we are considering as a subnet mask. Means on that basis only we are going to be consider what is subnet mask, and what is host bits and what is network bits. Okay. This is I have covered this first topic, what are TCP IP explanation. That one I have covered from this. Now we are going to be cover second topic. Okay, like setting up the Linux network. Okay. Now if it comes to the Linux, there are number of methods. Okay, how we can assign the IP address to the Linux host or Linux OS. Okay, in this demonstration, I am going to cover the three types of IP address schemes. Okay, like how all three way we can provide the IP address to the Linux host. Introduction will cover. We need three fundamental piece of numerical representation. Now only we learned in first half. Okay, like what is IP address, what is the gateway. Gateway is the first IP address of the usable IP address. Means whatever the traffic is provided in whatever the LAN or LAN. Okay, then all traffic should go to the gateway IP address. Mostly gateway IP address is configured with the routers only. Means whatever the traffic, if you want to communicate outside world, then whatever the subnet is there, all subnet host will provide the network traffic to the gateway IP address. We need to mention these things like what is the gateway for that network, what is the IP address, and what is the net mask. Net mask is like in the sense subnet mask only. Okay, in case of Linux, they are telling net mask. This is the term they are using, but this is the same as a subnet mask only. And all these three things are 32 bits only. Okay, and we are having two schemes to assign the IP addresses to the Linux source. Like we can assign the IP address statically. Like we can decide what is the IP address we can assign, and we can use the DHCP server also. Okay, I will go in next slides. This is the symbolic representation of the networking. Okay, first type is like at the time of installation we can provide the IP address to the Linux OS. Okay, Anaconda installer lower is there. Okay, which prompts for the network configuration. We can complete this network setting there itself. Okay, I'll show in next slides what kind of screen will come here. If you are able to see, this is the starting of installation. Here network and hostname is option is there. Okay, it's showing not connected here. We need to click there. Okay, and then we need to decide. I'll show you what is there in exactly next slide. Here is the thing. Whatever the interface is connected to that OS, Linux OS. Okay, it will automatically detect, but it will show as a disconnected here. If you are able to see interface name, this is Ethernet ENP0S3, it is showing, right? Then this is the interface name. Now it's off. Then from GUI terminal, we need to make this as a on. Then on the basis of IP address scheme, like whatever we are using static IP address scheme or dynamic host control protocol like DSCP. On that basis, it will accept the IP address. If you are using DSCP, means no need to give the IP address manually. Okay, it will take automatically. If you want to give the IP address manually, then we can give the three fields like IP address, gateway, and the subnet mask only. Okay, I will see in next screen. This is here from off to on I have done, and here I have selected as a DSCP only. Then that's what it is taken the IP address. If you are able to see here 10.0.2.15/24. Slash 24 means this is like class C IP address, and default route is 10.0.0.2. Okay, this is like whatever the traffic is flowing in this slash 24 network, all traffic should go to the 10.0.0.2.2. Okay, this is the gateway IP addresses which is provided by the DSCP server. Okay, while configuring DSCP server, we can decide these things. Okay, what is the gateway IP address, what is the DNS IP address, and DSCP IP addresses, what are the available IP addresses, next IP address it will give to the OS. Okay, and this is the first method. Okay, in this way we can assign the IP address to the Linux host. Now we'll check for the next method. This is the second method. After going to be installation, we have to, here I have marked this one, we have to click on this socket symbol. Okay, here it will show, and wired connected off turn means wire connected, it's showing here. Okay, here we need to click and we'll get this prompt. Here also we need to, from off to on we need to select. Okay, and that setting is there. Then it will ask for the, if you want to assign the IP address statically or dynamically. Okay, it will show here. if you are able to see here, automatic DSCP, which is selected here, for that reason it has selected this IP address. Okay, and from DSCP only, what are the parameters I told, it will check DNS also, route also. Route means this is gateway IP addresses, this is hardware address means this is MAC address of this interface, or we can say OS also. Then this IP address is directly assigned from the DSCP server. If you select the manual here, okay, then we have to assign these IP addresses, route and DNS server IP addresses, all these three things manually. Okay, this is the second method. This we don't need to do the things like at the time of install. After installation, we can provide these things. Okay, I'm going to explain the third method now. This is third thing. Okay, most of the time Linux, some of the users are using command line only. And whatever the things we are configuring in GUI mode, all those things are going to be stored in one of the file only. This is the file based system. Okay, and file path is /etc sysconfig network script. If you go to here cd, cd means change directory. Okay, change directory is the command. Like I will explain about those commands also later. Okay, when we will introduce with the command. Okay, whatever the basic commands we use to it. This is the file. Okay, if cfg enp0s3. Okay, if you are able to see what is this file exactly, this is the interface name. ifcfg is the utility. Okay, whatever the things are going to be stored, those will be getting stored in inside that file only. Okay, suppose if we are in this case also, if we are going to be use the DSCP method, then in that case we will not able to see the IP address says detail in that file also. Okay, it is controlled by the network management facility. Okay, this is NMCLI. If you go in command line, if you use NMCLI command, there also you will get the GUI representation. Okay, that is also one another method to assign the IP address to the Linux host. Okay, the relevant bit of information here is to use DSCP. For this snaps, we have used the DSCP method. Okay, which is used to collect those three important network numbers, like which are IP address, gateway, and DNS information. Okay, these numbers are not recorded in etc sysconfig network script and ifcfg, what are the enp0s3 file, because we have used the DSCP. And how we are going to be decide this scheme or this host should use the DSCP scheme. Okay, there one important field is there. If we select DSCP as a boot proto, that time all those things will be getting selected via DSCP only. If we select here static or none, that time we need to use the give the IP address, subnet mask, and gateway. Okay, these things that time we can edit manually in that file itself. Okay, that entry means every time this system boots, it will collect its network information from the DSCP server. Yes, because whatever the IP address is assigned from the DSCP server. Okay, and suppose if that host goes down, then that IP address get released to the DSCP server back. Okay, then whatever that means, next time if that server is getting rebooted or if it is get turned up, then whenever it boots up, okay, then it will again ask for the IP address to the DSCP server only. Then when DSCP discover message will goes to the DSCP server, it will assign the whatever the available IP address, next IP address to the client. It will give to the client. Okay, that but whatever I have already explained to you only. Okay, the interim is every time this boots, it will collect its network information from the DSCP server only. DSCP server only will decide whatever the IP address we have to give to the host system. Okay, but remember, the system doesn't store those numbers in the file. Okay, and it will store them in the RAM and sets the configuration. Okay, because that information, if it will save in RAM, means if it is not going to be saving in case of DSCP scheme. Okay, on the for this scheme, I would like to share this slide itself. Like if you check here, cd command is there, like change directory, we have changed to this path only, network script, whatever I was trying to explain there. And then if I'll do ls means file listing. Okay, then I am getting this file ifcfg enp0s3. This is the interface name. Okay, whatever the enp0s3 is going giving, that is interface name. Okay, and if I will do cat means it will show the content of that file. Cat means content means it will show the content of that file. If you are select here, this is type of ethernet. How many types of logical ports will be there? There might be wireless port also there, but this is ethernet port. Okay, proxy and those things we have selected. No, browser only, no. Boot proto, this is the important parameter. If here DSCP means whatever the IP address and DNS and route information, it will not detect display here. Okay, but system will get the IP address. If you select here static or none, instead of DHCP. At that time, we need to give the IPv4 IP address, IPv4 net mask, and route also we need to give. All these things we need to mention here. Okay. And one more important parameter here, on boot yes. Okay. Suppose if you give off on boot no, means whatever, every time system will get rebooted or turn on and off. Okay, it will not request for the IP address, or that ENSP03 interface will not come up. Okay, then this is must. Okay, on boot yes we should give here always and every time. Means whatever the scheme will be there, like static IP address or the DSCP IP address, it will go for the DSCP discover. Otherwise, it will not come. Okay, that's it from my end. Thank you. Thanks for attending this demo. We can, like, you guys can share feedback and contacts, or if any queries are related to this course, or any schedules or references, cost and payment options. All this means, if you are having any kind of queries or doubts, you can contact with this email information and numbers which we have given here. Thank you. Thank you so much.